Now, the next question is, how can a reaction get going? How can you provide the activation energy to make a reaction start? Clearly, the sugar sitting in your pantry is not getting enough activation energy for it to burst into flames. Thank heavens, right? Um, so generally, to make chemical reactions happen, like in chemistry class, you tend to heat things up, right? That's kind of like a standard thing. You put heat into the system, heat up the molecules, and that can start to pull apart the bonds. So that's what this is saying here. This is a fancy way up here of saying heating it up, increasing the thermal energy of the reactants. All right, that isn't very practical for living organisms. What I mean here is that let's say you ate a bunch of protein or starch, right? Some big long molecules, and you have swallowed them and they're in your stomach. Your stomach is at 37 degrees Celsius or 98.4 degrees Fahrenheit. And you want to digest those food molecules apart. You want to break down that protein chain into amino acids, or you want to break down that starch into glucose. But 37 degrees Celsius body temperature is not warm enough. It's not enough activation energy to get over that hump. It just isn't enough. It's not warm enough to break down those molecules. So using this thermal energy idea, what you'd have to do is get a Bunsen burner and put it on your stomach and heat up your stomach to get the chemical reaction to start. Well, clearly that is not practical. You're not going to do that. So you have to come up with a different way to get over that energy of activation hump that the chemical reaction needs to break down the food molecules or whatever molecules you need to break down in your body. So this is how you do it, and this is how living organisms do it. We use special chemicals called enzymes, and enzymes are protein molecules that actually lower the activation energy that a reaction needs to get going. So they lower that hump. Instead of having to go over a hump that's this high, which means you have to heat it up this much, they make the hump only be this high, so you only have to heat it up this much. So they make it so that the body temperature is warm enough to get over that hump. So when the enzymes are present, they can help the reaction happen at a lower activation energy. They do that by generally either, if it's a breaking down reaction that you're doing, the enzymes can sort of grab onto the molecules and kind of tweak and bend and twist them and put the bonds under stress so they ping apart easier at a lower energy. Or if it's a reaction where you're trying to stick two things together, they can actually take the two things you're trying to stick together and push them together so that they more easily can make that bond between themselves. So enzymes can help both breaking down reactions and building reactions. They just make the activation hump that you have to get over lower so that your body temperature is sufficient. All right, so here's a diagram of what I'm talking about. For some reason, that graph isn't showing here, so let's draw the axis. There's the y-axis, there's the x-axis. So if in this diagram we start off with reactants are here, the reactants are right here, and we need to put them together to make products which are over here. Overall, this looks like this reaction should just go because it's downhill, but it's not going to just go because we have to get over this hump first. All right. If there's no enzyme around, you have to put this much energy in to get this reaction to go. All this energy here, this is the EA without an enzyme. But if you add an enzyme into the mix, and the enzyme can help things out, the enzyme makes it so that you only have to get up this high for this reaction to be able to go. So if this was in your body, maybe this is like 37 degrees Celsius. Maybe this is like 60 degrees Celsius. So without an enzyme, you have to heat this up to 60 degrees to get it to go, which is impossible. You can't get your body that warm. You can't lie on a hot plate or a Bunsen burner. It's not going to work, right? But you can have this reaction go at 37 degrees if an enzyme is helping it out. And luckily in our bodies, we have hundreds of different enzymes that help with all the hundreds of different reactions that we need to get done so that all those reactions can happen at 37 degrees Celsius or body temperature when they wouldn't normally. In the next presentation, we will talk more about how enzymes physically work and how they function.